Good morning, welcome to your first proper online teaching lesson. Hopefully the teething problems from yesterday are finished and we can get on with some really good learning. So this is your first maths lesson and as promised we're going to be doing lots and lots of work on fractions in particular this term. Starting off with adding fractions, and I know you are all amazing at adding fractions, and we're starting off really gently today. We're going to look at adding fractions within the whole, so they're proper fractions that we're adding within the whole, so our answer will still be a proper fraction. We're not going over one, we're going to stay within that, still parts. And one of the denominators is going to be a multiple of the other. So we're making it really, really simple to start with. Now, because of that, we're going to do two learning objectives in one, but I'll explain to you how that's going to work in a minute. So this is the first one, and a little problem. You know I like a truffle, or two, or three. So on Christmas Day, I ate a third of a box. Good start, my pen isn't working. Okay, let's try another one. On Christmas Day, I ate a third, that's better, of a box of truffles. It's a proper fraction, you can see. The denominator is larger than the numerator. And then on Boxing Day, I was really hungry. So I ate 4/9 of the box. Okay. Again, we've got another proper fraction. So I want to know what fraction of that box did I eat all together? Okay, now let's have a look. We know that we cannot add apples and pears. It doesn't work. If we want to add fractions, they've got to be the same size parts. They've got to have the same denominator. Now, I can notice by looking at those that 3 and 9 are both factors of 9. So I'm going to convert these so they are both in ninths. We've then got apples and apples, or pears and pears, or bananas and bananas, and we can add them very simply. Now, we've done lots of work on finding equivalent fractions, and I think a lot of you now very quickly can see that we multiply 3 by 3 to get 9, so we also need to multiply our numerator. Okay, which gives us the question now, 3/9 plus 4/9, very simple to add together and give us 7/9. Yes, I did eat 7/9 of a box of truffles, meaning there were only 2/9 left to share around. Okay, I think I need to be doing some Joe Wicks now to make up for it. Now, if you want to see it visually, we could draw a bar model. I don't think you probably do, but it might help. So if I draw I'm going to just make this easy for me. Okay, so there's my whole. I'm going to divide it into thirds, and on Christmas Day, I'm going to eat that third. Now, where do my ninths come in? Well, because 9 is a multiple of 3, if I were to divide each one of these, each third, into a thirds, I would have 9 parts. So on Boxing Day, I'm going to eat 1, 2, 3, 4 ninths. So that bit is 4 ninths. And if we count them together, 1, 2, 3, 4, 5, 6, 7, we can see that we've now got 7/9, the same as the numbers. Okay? I think you've got it, but I'm going to do one more just in case you want another example to follow through when you're doing your homework. So this time I'm going to go for 2/5 plus 3/10. Okay, so I noticed that 5 and 10 are both factors of 10. 10 is a multiple of 5. So I know I'm going to convert my fractions. So they're both in tenths. That one already is in tenths. I've then got the same denominator, so I can just count the parts. Now I need to multiply 5 by 2 to get to 10, and so I multiply 2 by 2, so my fraction remains equivalent, it keeps the same value. So that's going to give me 4, and again I've got a numerator of 7, but this time it is 7/10. Okay, quite straightforward. You've all been doing this without even realising in our arithmetic test, so although you've not had the teaching to go with it, you've made the links from what you already know and you've been doing it. Okay, so what I want you to do now is do the first do it and the first secure it. Okay, don't worry about the deepen it yet. We can go on, or rather go back and do the deepen it afterwards. So do it and do your secure it. Give me a pause now and then come back to me when you've done those, and I'm just going to go through the second part of the lesson. Okay, good luck. Okay, if you're back with me, you must have already done the first part of the lesson. So now we're going to just move this on a little step further. So we're still going to be adding proper fractions. They're still going to be within 1. We're still not going to go over into mixed numbers or improper numbers yet. We will be, but not yet. So they're just not multiples of each other, the denominators. Okay, so back to my truffles. I'm going to move this down, I think, just a little bit so I can use the whole of my flip chart. Yeah, there we go. Okay, so back to my truffles. This time I ate a quarter of the box on Christmas Day and 4/6 on Boxing Day. Okay, what fraction again did I eat altogether? Well, apples and pears, different denominators. We need to do something. 6 isn't a multiple of 4 this time. So what do I notice? Well, let me have a look. I notice that 4 and 6 are both factors of 12. 12 would be the lowest common multiple of 4 and 6. And if you remember, the quickest way to find that out, the most efficient way to find that out, is to start with your largest, your denominator with the largest value. So is 6 a multiple of 4? No. Is 12 a multiple of 4? Yes, it is. Okay, so we're going to use 12 as our common denominator. Right, how many 4s are in 12? 3. So I need to multiply my numerator by 3. So 1/4 is equivalent to 3/12. And then 6 goes into 12. 2. Multiply that by 2 gives me 8. Now simply add them together. Our denominators are the sizes of the parts. They're both the same, so now I can just add them and I have got 11/12. Okay, right, one more example for this one and then I'll set you off again on your own, and I think we can just about get it on the bottom of the page. So this time I'm going to say 2/5 plus 1/4. Right, I need to work out my common denominator here. There's nothing jumping out at me, so start with my denominator with the higher value. Is 5 a multiple of 4? No. 10? No. 15? Definitely not, it's odd. 20? Ah, that would be it. Okay, so I'm going to use 20 as my common denominator. 4 5s are 20, so 4 2s are 8. 2/5 is equivalent to 8/20. I need 5 4s to make 20, so I need 5 1s. Add them straight away. 13/20. It is as simple as that. There's nothing to it. There's nothing that you can't already do, because you've already found equivalent fractions. You've already found common denominators. You can find You can notice factors, you can see the multiples. So you are really good to go on this. Okay, so now I want you to do the do it and the secure it from the second section. And then when you've done that, go back and spend a bit of time looking at both of the do its if you feel you can have a go at that. If you struggle, drop me a message on Teams and I'll get back to you as soon as you can. All right, take care, have a good go, and I'll see you later. Bye guys.